Hello, grade 11s. Okay, so let's jump and dive straight into it. We're doing heights and distances, of course, as we're making maths, and heights and distances in one plane. And we got two examples, two different videos. So the first one, we've got this picture here over here where from the top of a building, the angle of elevation of the top of a nearby tower is 25. So I think if you're standing on top of that building and you're looking up at the other one, then it's 25, and if you're looking down, what do you reckon? Maybe I should go and stand on top of that building and check it out. What do you think? Okay, well, hopefully you said yes, because do you know what? Let me go and stand there. Come on. That was too good. Okay, so there we were, standing on top of that building, and we could see. So out of this whole story, we get given the picture there. So this person, there they were, standing over there. And so if you drew a line straight across, we told that that's kind of the distance from the one building to the other building. And so let's call that D. And so if we drew it at kind of ground level, it would also be D. Now, if you looked up towards the top of the other building, then that angle there is 25 degrees. And if you looked down at the bottom of the building, then that would be 20 degrees. Okay, so you oriented yourself of what's happening in the picture, and we're given some distances. So we're told that this entire distance here of this other building is 30 meters. We know that this tower here is 30 meters high. So therefore, if we let this side of our triangle be x, then clearly the other side, or the side of this other triangle over here, this is 30 minus x, right? Because the whole thing is 30, and that's 30 minus x. Okay, so pause, take a breather, jot down the diagram, pop a yes or woo, wow, when you're done and ready. And let me get back in here. I still think that was a bit of fun. Okay, so here we are. So now what we need to work out is how far away is the tower from the observer? So in other words, the question is asking us, what is D? So we using our trigonometry, and if we can work in right angle triangles, all the better, because we can use sine, cos, and tan, just in our right angle triangles. But if not, we can always use our our sine rule, cos rule, area rule. Now, clearly not area rule, because we're not interested in area. So let's set things up. I see some nice right angle triangles here. So let's start with maybe x and say, well, we can use one of our trig ratios in this top triangle. So that triangle that looks like that, with that's 25 degrees and it's a right angle, we got x and d. So from the 25 degrees, which trig ratio are we going to use? Sine, cos, or tan? And why? Okay, well, I would use tan because we've got opposite and adjacent. So we know from this triangle here, which is the top triangle, let's leave it up there actually, we know that tan of 25 degrees is x over d. Okay, that seems quite useful. Now, why don't we do something similar in the bottom triangle? So in the bottom triangle, let's draw this and go, okay, there we go. That's still d. This distance we don't know the hypotenuse. This is a right angle, and this is 30 minus x, and this is 20 degrees. Now, given that you've got opposite and adjacent, which trig ratio are you going to use? Okay, well, again, it looks like tan, right? Because in this one, let's go purpley pink and go, well, tan of 20 degrees is opposite 30 minus x over d. Now, since we've got two equations, let's call that equation 1, and this equation 2. We've got two equations. We've got two variables. How are we going to solve? Well, it's just crying out for simultaneous equations. You know, the 1 into 2 or 3 into 2. Yeah, you know you know I'm speaking to there. So let's go for it. So if we could rearrange one of our equations, then we could sub it into the other one. So let's say that this equation, I don't know, I would solve it. In fact, yeah, how about that? It's simultaneous equations. So give a go at solving it, and then just write down what your experience of solving it was. Then I'm going to do it, and the reason I'm pausing is that my method may be slightly different to yours, and there are going to be a few ways to solve it simultaneously. So let's go for it. So you go for it, and now I'm going to go for it. How about that? So if we've got this equation, I'm going to stick with and multiply both sides by d. D tan 20 degrees equals 30 minus x. Okay, I don't know if that really helped us, but maybe in the other equation, I like to kind of have them side by side. Tan 25 equals x over d. Well, if we multiplied both sides by d, then d tan 25 equals x. Oh, well, maybe this would be useful enough. So let's put this version of x into the other one. I don't know, maybe that would be useful, or maybe, yeah, I don't know. As I said, there are going to be so many different ways to solve this, and I feel like I do it slightly differently each time for any kind of simultaneous equation. So that's 3, and this is maybe 4, so I'm going to go 3 into 4, and I don't know, let's see, maybe you get something different. So over here, I've got d tan 20 degrees equals 30 minus, now instead of x, I'm going to write d tan 25. Doesn't look like I've chosen the easiest method here, because I'm going to have to add this, so I've got all the d terms on one side. D tan 20 degrees plus d tan 25 degrees equals 30. Take out a common factor here. Tan 20 plus tan 25 equals 30. So d equals 30 over tan 20 plus tan 25. Now let's just see. Yeah, I feel like I've not chosen the easiest method here. Tan 25, I don't know. Well, it'll work though, because we can just punch that into our calculator. So somewhere over there, your calculator magically appears. No, wait. It wasn't called a calculator. No, don't worry. It was a magic machine. It was that thing in place of our brains. It was. Now the others will come back to me as well. Those are goodies though. So yeah, into our magic machine, let's go for 30 over tan 20 plus tan 25, and we get 36,13 meters, or whatever unit you happen to have. So yeah, that should be what we've got. I'm going to take a pause and be back in a second. And I'm back. I was just rechecking on the sponge, or oh yeah, the maths genie. Okay, well, on that note, the maths genie, you're like, what did he do? Okay. Okay, cool. Well, you know what? Make it maths. Enjoy. See you in the next video shortly for the second and final example.